Hi, this is your instructor Kumaran here. We are now going to see in this section about distributions, statistical distributions or probability distributions. Distributions are a visual way of summarizing and showing trends. And if you have been used to analytics, you would be seeing a lot about these distributions that in your real life. So what is a distribution? Distributions show how the data values are spread in a given observation set. So you have a set of data, you've collected number of observations or samples or examples, and then you're trying to find out how these values are spread across in a given data set. So how do you do distributions? Distributions basically contain a set of bins. The bins are groups are shown on the x-axis. So in this example chart on the right side, the bins are actually like the types of feedback you get, like excellent, very good, good, fair, and bad. So each one is a bin, and then you count the number of observations that occurred in each of the bins. So suppose you collected feedback from say 50 people, and then you want to show how many excellence you got, how many very goods you got, how many goods you got, and this is how you show them in a distribution. Is you take each of the type of rating and put them on the x-axis, and then the count that you find is put on the y-axis, and this is how a distribution would look like. This is how you do for a categorical or ordinal data. What about interval or ratio data? In the case of interval or ratio, the bins are usually ranges of values. You convert them into ranges of values like 1 to 10, 10 to 20, 20 to 30. Typically, they are equal sized ranges, and then you show how many values occurred in each of these ranges. That is how you would do a distribution for interval or ratio data. Here is an example of how you would build a distribution. So on the top, you see like 10 numbers. So this is your data set. The data set has 10 numbers in them, and I want to build a distribution. How do I do that? First, I create bins. The bins are shown here is I'm trying to create bins in the range of two numbers like 1 to 2, 3 to 4, 5 to 6, 7 to 8, and 9 to 10. And then every value is taken and put into the corresponding bin. So the first value is 4. I take this 4 and put into the bin 3 to 4 because that's the range it falls into. Then you take 7 and put them in the bin 7 to 8 because that's the range it falls into. And then you keep doing that for every value that you find in the data set. And then finally you count the number of values that occur in each of the bins. The number of values from 1 to 2, in the bin 1 to 2, there are 3 values, you count 3. So once you have the count and the bins, you plot the bins on the x-axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and plot the counts on the y-axis, and then you put in the points or bars or whatever you want to show. And this is how you build a distribution chart for a given set of data. Now, when you have distribution, there are different shapes you end up when you make a distribution. So when you try to draw a smooth line on these plots, or here let's say go back to the earlier distribution and you try to draw a smooth line on the plot like this. So once you draw a distribution, you can actually draw a smooth line on the top of all the bars or the top of the points. You get a shape, and the shape typically determines what kind of distribution it is. So there are different types of distribution like the J-shaped distribution. You see the values are the lower bins have a lot of values than the higher bins. In the case of a normal distribution, you see that the middle bins have the most values, and the lower and the upper bins do not have that many number of values. In the case of a rectangular distribution, all the bins have equal number of values. In a bimodal distribution, you see the two bumps or two mountains in the distribution. So that's why it's called bimodal. So there is on the lower side, there is a bin that has a lot of values. On the higher side, there is one bin that has a lot of values. Then there is the positive skew and the negative skew, where in the positive skew, one of the lower bins typically have a more number of values. In the case of a negative skew, the higher bins have more number of values. And this is how the distribution, there are different types of distributions that are typically there. Then comes the most important thing called probability distribution. So what is a probability distribution? This is a little complex concept if you want to pay more attention to trying to understand it. So it assigns a probability to each measurable subset of possible outcomes of an experiment. Okay, there's a lot of complexity here. Let's rate it one by one. You have an experiment. An experiment is nothing but I'm collecting data. So an experiment may be like I'm trying to find among 100 patients, what kind of outcome. Suppose I have 100 patients and I want to find what are the age ranges of these patients. When I want to measure age ranges of these patients and I want to plot a regular distribution, what I would typically do is I want to take the age of these patients, 100 patients, and then put them in buckets of 0 to 10, 10 to 20, 30, 20 to 30, like that. And then I want to put the count on the y-axis and draw a nice plot. Now that is a regular distribution. Now what is a probability distribution is instead of plotting the count on the y-axis, I'm going to plot the probability of each of these ranges occurring. So how do I do that? Let us go back to the earlier plot and then show you. Now here is the earlier distribution you built where the bins are shown on the x-axis and counts on the y-axis. Now I just change the count to probability, and how will I show the probability of each of these bins? It is very simple. You just take the count in each of the bins divided by the total number of values, and that becomes the probability for each of the bin. So in this case, the total number of values is 10. The count in this bin 1 to 2 is 3. So 3 by 10 or 0.3 is the probability of the bin 1 to 2. 0.2 is the probability of the bin 3 to 4. So you plot probability on the y-axis, bins on the x-axis, that becomes your probability distribution. Now let's go back to the other slide and start digging in a little deeper. So in this case, let us say I have age on the x-axis and the probability that a patient has that age is plotted on the y-axis, which you are measuring by saying I'm collecting data from 100 patients and then I'm putting them all into a distribution and then converting it into a probability distribution with the technique we just talked about. So each possible range is plotted on the x-axis, which is, as we said, age 0 to 10, 10 to 20, 20 to 30. And then the probability that particular age group occurs is plotted on the y-axis. Probability is always a value between 0 to 1. So we saw that it may be like if 30 patients out of 100 patients are of the age group 20 to 30, the probability of 20 to 30 is 30 by 100, and that is 0.3. You can have probability distributions to be either discrete or continuous. Discrete means they can be just bins, or it can be you can use them to plot continuous set of values and then plot a nice curve around them too. So you can do both in terms of probability distributions. One of the most popular distributions that you see is called the normal distribution or the Gaussian distribution. So what is a normal distribution? A normal distribution is a distribution where when you plot values of a given data set on a chart, it takes the shape of a normal curve. So you plot the values on a chart on a given data, and the data takes what is called a normally looking curve. What is a normally looking curve? Let's look on the right side chart. A normally looking curve typically has they're symmetric about the mean, which means you take the mean, which is the middle bar. You see the chart being symmetric. Both sides look typically the same. There is no skewness on the left or skewness on the right or anything like a bimodal or anything like that. So it is equally symmetric about the mean. And there are other characteristics about a normal distribution, and that is to say, let's start with trying to understand what each of them mean. It says about 68% of the values lie within one standard deviation of the mean. What does that mean? So the mean is plotted on the middle, which is we call here x bar. We could have also called it here mu. There is a slight difference, but we don't want to go into that. And then what is x plus 1 sigma and what is x minus 1 sigma? Suppose in a data set the mean of the values is 5 and the standard deviation is 2. So x plus 1 sigma is 5 plus 2, that is 7. X minus 1 sigma is 3. So between 3 to 7, 68% of the values occur. So if the data set had 100 values with a mean of 5 and standard deviation of 2, 68 of them would be between the values 3 and 7. Let me repeat. I have a data set of 100 values with a mean of 5, standard deviation of 2. 68 of them will be between 3 and 7. That is mean plus 1 sigma and mean minus 1 sigma. Then you say 95% of them will be between within 2 standard deviation of the mean, which means 95% of the values are going to be between x plus 2 and x minus 2, which is 5 plus 2 into 2, 4. So 5 plus 4 and 5 minus 4. Between the values 1 and 9, 95% of the values would be occurring. So it just shows you how the values would be evenly distributed, and if the values are distributed in this manner and conforming to this particular shape and to these numbers, it becomes a normal distribution. So why would you want to find out if your data is normal or not? Because once you know your data looks like a normal distribution, there are a lot of standard regular built-in formulas that you can typically start applying. There are a set of regular assumptions that you can start applying to your data. You don't have to sit and compute a lot of stuff. A lot of things are already computed for you. There are formulas and libraries available for you, which you can start using if you know your data is normally distributed. And typically it is also said that most of the data sets that you find will be normally distributed like this. Okay. On the left side, you see another chart which is giving you how the normal distribution will look like for different values of mu and different values of variance. So sigma is standard deviation, sigma squared is variance. So for different values of mu and standard deviation, how do these values look like? Just the first curve is very narrow. That is because you see the standard deviations or the variance is pretty less. As the variance keeps increasing, the height of the curve goes down and the spread of the curve goes up. So that is how you see different normal distributions take shape. Here is an example of a normal distribution. It is about employees of a cereal factory. It shows about the number of years people worked and how many people fall into that particular number of years category. So the number of years is plotted on the x-axis. The frequency is plotted on the y-axis. Means the number of people. So let's say then when you look at the number of years worked is 8, there are 137 people in that particular bin. And the mean of this data is 10.2 and standard deviation is 4.1. So when you look at a figure like this, it immediately gives you a nice picturization of how the data is spread. If you look at just this picture and says, okay, this is how my data looks like. The mean is around 11. You just look at the chart, you can easily see the mean is around here 11. The data is nicely spread around, not skewed anyway. Immediately you can make some assumptions regarding that. Next comes a very important distribution called a bimodal distribution. Now, binomial distribution. A binomial distribution is about data where the data is either a 0 or a 1. It is not a number, it's usually a 0 or 1. Suppose you have a test which says you have a set of 100 patients and you want to say does this patient have cancer or not? So that is a test. So you have 100 patients, you ask this question 100 times. For each of these patients, you have an answer which is either 1 or 0 or yes or no. Since it is only two possible values, that is why it's called binomial. And a distribution for that kind of a data is called a binomial distribution. So how do you plot a binomial distribution? Suppose you have, it basically describes the probability of a Boolean outcome, which is to say that if I have 100 patients, what is the probability that 30 patients or 30% of my patients will have cancer? What is the probability that 50 of my patients will have cancer? What is the probability that 70 of my patients will have cancer? That is what a binomial distribution usually tries to answer. So let us say the example on the right side, maybe we have like 10 patients. Okay, and out of these 10 patients, we are trying to find the probability. What is the probability that 2 patients have cancer? And that probability is 0.2 or 20% of my patients. What is the probability that 5 patients might have cancer? And the probability is somewhere here like 0.12 or 12% of the patients. So if you have like n number of trials, in this, a trial is nothing but the number of observations, in this case of the number of patients. If I have n number of patients, and I have k is the number of successes, or k is the number of patients among this n who might have cancer, what is the probability? You're trying to draw a probability distribution and say, okay, what is the probability that 10% of my patients, 20% of my patients, 30% of my patients will have cancer? So this is a plot of all the probabilities. So the probability is plotted on the y-axis, the number of observations on the trials on the x-axis, the number of patients, and then you just draw a bar as to how you want to look at that. Here is an example of binomial distribution. In this case, what you are doing is you are trying to flip a coin 4 times. When you flip a coin 4 times, which is nothing but 4 observations or 4 examples or 4 trials, for each trial, you're going to get a binomial output. It's going to be either head or tail. So there are only 2 possible outputs of every trial, head or tail. Then you're trying to take all the 4 trials and see how many total heads can I get. So when you do a flip of coins 4 times, these are all the possible combinations. There are 16 possible combinations of how you would get head or tail, and they're actually shown here. You can either get head, 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 tail, or maybe somewhere like head, tail, tail, head. So out of these 16 observations, you're trying to find how many times I will get in this. You try to put a chart here and say x is nothing but the number of heads. So how many times you will get 0 heads? So that is 1, which is when you get all tails. So 1 out of 16. So for 1 out of 16, the probability 1 divided by 16 is 0.0625. What is the probability I will get 1 head only? You get 4 times in this list. You will see there are 4 times you will only get only 1 head. So that's 4 by 6. How many times I get only 2 heads? That is 6 by 16. Only 3 heads, 4 by 16. When do you get 4 heads? That is 1 by 16. So you have this nice probability that is coming up here, and then you go ahead and plot this, the number of heads you would get on the x-axis and the probability on the y-axis, and you then get this nice bell curve like this. So this is what an example of a binomial distribution, and you can use this to figure out, what is the probability I'll get 2, and then you can look at, okay, this is how the probability is distributed across. So that completes our discussion about distributions. Thank you.